In this question, there is a steel tube of length L. So this is the tube, inner radius R and outer radius 2R. So this is inner radius R and outer radius 2R. It is fixed at one end. So I fixed it here. The modulus of rigidity of this tube is eta. The torque required in twisting the steel tube through an angle of theta about its axis that we need to find out. So that means this is the axis. About this axis, we are twisting it by an angle of theta and how much torque will be needed. So let us see what is the concept needed for this question. The concept is we should know the relation between angle of twist and angle of shear. Now you can refer to this diagram. So here cylinder of length L, radius R. So this is length L cylinder and radius R cylinder. It is fixed at one end and tangential forces applied in the another end. So here we are applying the tangential force and cylinder gets twisted, right? So here now, if you see carefully, there are two angles. One angle is this phi. You can see the small angle. Another angle is this theta. So when you twist it in this direction, then this is the straight line AB. So since B point is fixed, it is not going anywhere. When you are twisting this surface, then A point will shift to A prime. Fine. So let us say this angle is theta. The AOA prime angle is theta. This angle is called angle of twist. The angle by which this surface gets twisted. Okay. Now here, if you remember, shear stress, shear strain was what? From as with respect to this surface, how much this surface get shifted, right? That is the shear strain. So for shear strain, this is the change in length, and that's the original length, right? This is what we take. So here, this phi, 10 phi, if you write a phi is very small, then phi you can write as AA prime divided by this length L. You know? So this is called angle of shear. Fine. Angle of shear and or shear strain, also you can call it phi. Fine. So that is what is written here. Phi is equal to r theta. This angle is r theta. And here also, since phi is very small, you can use angle equal to arc by radius. So this, you can call this as, from this triangle, you can call this as L phi. So L phi is equal to r theta. So you get phi, which is angle of shear in terms of angle of twist, right? This is what we are going to use here to find out the torque. So let us see the solution now. So I have drawn here one section of that cylinder. Inner radius is r, outer radius is 2r. And this surface gets twisted by theta angle. So if you consider a small part of the cylinder, then what will be the shear strain? Just now we have calculated. It is r theta divided by L. L is length, right? You can refer to the previous diagram. Then shear stress by shear strain is modulus of rigidity. So shear stress will be equal to modulus of rigidity into strain. Fine. Now this is the stress. So how do we find force? Tangential force, stress into area. Which area we have to take? The area which is highlighted in white color. So it is 2 pi r dr, right? This distance is r. So what I have done here, stress into area. This gives us the tangential force and this tangential force, right? Like this. And then since we have to find torque about the axis, perpendicular distance is r. So this is the perpendicular distance r. So this is d tau, which is acting on this white colored small surface. So to find out the torque on the entire surface, we can integrate this from r to 2r. So if you integrate, you get 15 pi eta r to the power 4 theta by 12. So that's the answer, right? It's a very good, I will say very important question for JEE Advanced, because questions based on modulus of rigidity are very less. You will not find many questions based on this concept in many standard books. Fine, so that's it. That was my analysis. And I think this is a highly probable question for JEE Advanced. So if you have liked my analysis, please hit a like button. Please subscribe to this channel also. Thank you very much. I'll see you again in next video.